Hi, my name is Jia Chen, TA of CS303E at UT. In this video, we are going to look through the computer case and take a quick tour at what are inside the computers, namely computer hardwares. So this big black box is what we call the computer case. You must have seen many of them. Modern computer case mainly has three functions. 1. Hold all the computer hardwares inside. 2. Block most of the electromagnetic waves emitted by those hardwares. And 3. Give your computer an amazing look. Now, in order to see those inside hardwares, we need to lay down the case and open it. Okay, here we go. So basically, this is what the inside looks like. Let's examine those parts one by one. The first part I want to mention is the power supply. Computer is an electronic equipment, so of course it will need a power supply to provide electric power. The position of the power supply may vary, depending on the case you buy, but most likely it should be installed on the upper rear corner or the lower rear corner. You can see there are many cables that extends from the power supply, connects them to the motherboard and other devices to give them the power they need. The square board on the bottom of the case, which contains lots of chips, circuits and slots, is the motherboard. The motherboard is like a backbone of your computer. It provides slots for many critical parts such as CPU and memory, as we shall see in a moment, and also contains a bunch of integrated circuits and chipsets that can keep your system functional. But be aware that many of those chipsets must be compatible with your CPU. An Intel CPU cannot be installed on a motherboard designed for the AMD CPU and vice versa. Now we're looking at the central processing unit, or the CPU of the computer. CPU is like the brain of the whole computer. Most of the general computation tasks are executed exactly here. Currently, the two dominant CPU manufacturer companies in the market is AMD and Intel. This one here is produced by Intel, as you can see. Actually, this whole big thing here is not the CPU itself, but the fan or the cooler of the CPU, which is used to reduce the temperature of the CPU. The reason why we need the cooler is because when running, CPU produces tremendous amount of heat, which can drive the temperature well above 200 degrees Fahrenheit, which will definitely damage the CPU. Here, I have pointed out 4 latches of the CPU cooler that are used to mount this cooler. If we rotate and pull the latches like this, we are able to take this cooler out and see what the real CPU looks like. However, I'm not going to do this because it will ruin the thermal grease between CPU and the cooler. But I can show you several pictures of my CPU I took before installation, and here they are. This 2 inches times 2 inches square is the CPU. This one here has about 700 million transistors inside it, and ideally it can finish up to 3.3 billion instructions every single second. Isn't that amazing? This is the memory bar of my computer. You may also call it the main memory or RAM. Does it look like a candy bar to you? Memory is rather critical to our system because most of the data that are processed by CPU are stored in these bars temporarily. Let's see how we can install it on our motherboard. Here are the slots for our memory bar. There are altogether 4 of them on board, and they are called the DIMM slots. When installing memory bars, you must be aware of the direction. See this tiny little crack here in memory, and this same crack here on the slots? Yes, they must match perfectly. If you are installing the bar in the wrong direction, the memory just won't work. There are 2 latches on both sides of the memory, here and here. Just press the memory down, you may hear a sound of a click. That means the bar is mounted successfully. You may notice here that I have installed 2 bars. Each of them has 4 GB memory, so together I have 8 GB memory, and they are automatically organized into 2 banks. These are the PCIe slots, including the long ones and short ones. PCIe stands for Peripheral Component Interconnect Express. It is now the dominant bus standard for input-output devices such as graphic cards, sound cards, and network cards. On the class, you may heard that we need a sound card and network card properly installed. It turns out that nowadays the motherboards are so powerful that they have already integrated sound processing chips and chips that dealing with network connections. For your information, in this motherboard, the sound chip lies here and the network chips lies here. This is my graphic card. The two big fans and those thermal tubes on board makes the card way too big. Although in these days, both the motherboard and the CPU may integrate graphic processing circuits inside, for a core gamer like me, a powerful graphic card is a must for those graphic-intensive game applications. This graphic card here contains about 2.8 billion transistors, 10 times more than the transistors in CPU. The installation of graphic card is simple. They are designed to be mounted on a long PCIe slot here. And you just have to match the slot, keep pushing it until the sound of a click can be heard. Let's see. Alright, we're done. We have installed this card on the motherboard. It's plug and play, very simple. But since this card is so big, you can see here that this card is not very stable, so we have to use a screw to secure it, like this. Now let's move on to the final parts. The hard drive and hard disk here and the optical disk drive here. These drives are vulnerable to any kind of vibration shaking, so we have to use a proper stand to support them. Let's look at the optical disk drive first. Optical disk includes CD, DVD and the Blu-ray disc. My drive here is a BD combo, which means it can read CD, read DVD, write CD and DVD, and finally read Blu-ray disc. It cannot write Blu-ray disc, otherwise it should be called a BD writer, not a BD combo. This lock here has the function of secure the drive. If I open this lock, I may be able to take the drive out. This is the hard disk drive. It is a traditional magnetic disk drive, not a recent solid-state disk, so this drive reads and writes at a relatively lower speed compared to solid-state disk, but has much more capacity. We can see from here that this disk may contain 1.0 terabytes. That is 10 to the 12th bytes. In other words, that's many data. Both the hard disk drive and the optical disk drive are connected to the SATA port on our motherboard. Now that we have finished introducing all the hardwares inside, let's close the computer case and connect it to those essential peripherals outside the case. Okay, now first we have to connect the power switch cable to our power supply, of course, and turn on the switch on our power supply. Some of the power supply may not have a switch, and that shouldn't be a problem. Okay, now I have to connect my monitor screen to my graphic card. I use HDMI cable here, and depending on your situation, you may choose to use DVI or D-sub cable. This is the cable for my keyboard. I have to connect it to the USB port. This is the cable for mouse. It should be also connected to the USB port. This is the cable for Ethernet connection. And finally, this is the cable for my speaker. Now let's turn on my computer and see what's happening. Oh, great, it works. As you can see here, I have installed two operating systems on my machine, Linux and Windows 7. Let's just using Linux for now. To test our computer and confirm it works, let's open the console and write a simple Hello World program. Here's the program. Let's see, Python 3 hello.py. Okay, great. Now this concludes our content of this video. You can see that computer is not and should not be regarded as something mysterious. You play around with these hardwares just like you play with Lego toys. Okay, thanks for watching and hope you enjoy this video.